window literally shatters. It's really astonishing.
It just doesn't make any sense. It's amazing how quickly and easily it destroys that window. What's going on?
Scientists, explain.
The key for shattering the glass in the car window is that the glass has actually been treated in order to make it safer for you. It's what we call tempered glass. Instead of forming these long daggers, it actually just crumbles up into tiny pieces when it's compromised.
The way this glass is treated is it's first heated to a very high temperature. Then it's rapidly cooled down. And what this does is create two layers. You have the outside layer where everything is in compression. The inside layer is more in tension. The whole system is overall balanced. It actually creates a very strong system.
To prove how strong the glass is, Mike tries the same trick with a pebble and a nut. But if it's so strong, what's going on with the ceramic?
So the difference here isn't weight or size of the object. It's really how sharp it is and how much pressure you can get. Pressure is equivalent to a force over an area. So if you have a very small area, you're actually going to get a very high force. And with the ceramic piece, it's got a very tiny area. So when it hits the glass, it applies a lot more pressure to the glass than the blunt object would.
So it's the internal forces within the glass that keep it so strong. But it's a lot like a house of cards. If you destroy the tension in one part of the window, the whole panel will fail.
Mike, what about the mess?
Vacuum.
Most of these video clips, you see people destroying things. You don't always see the cleanup. It's nice to see someone take responsibility.
And remember, broken glass can be dangerous. You have been warned. Camera, it's impossible to see what's going on. So it's time to check out what our high-speed camera has captured. And there it is, the needle rocketing through the glass and out the other side. Amazing.
Yes.
Now we've seen it happen, what exactly is happening?
The speed that he's throwing it. He's throwing it at 150 kilometers an hour. That's nearly 100 miles an hour. That's how fast it leaves his hand. That is at the edges of what you think a human is capable of. Divided by area, we know he's got immense force with that needle. We also know the area is tiny. That means he's creating this huge pressure, and that is enough to burst through the glass and out the other side. It's incredible.
But why doesn't the glass shatter?
Now, the reason that it does this is because glass is a little bit freaky.
Glass, despite all appearances, is not actually a normal solid. It's what's called an amorphous solid. And this means that when it gets hit by a needle, it doesn't immediately transfer that force across the whole plane. It means it can be focused and stay quite localized.
And if you're thinking of trying this, don't. It took Shifu Shi Yanzhu a lot of practice. You have been warned. Military contractor destroying 100 tons of weapons in Iraq. But what our experts are witnessing is the anatomy of a super-sized explosion.
First thing you see is the light that's formed from the explosion. And the second thing is that you notice the tripod of the camera shakes, and this is because a shockwave from the explosion has traveled through the ground and is now shaking the tripod legs. And the third thing is that we hear the explosion and we hear the sound.
And that's a clear illustration of the difference between the speed of light and the speed of sound.
Very interesting. But what in the name of science is that?
You see what looks like some sort of a halo effect. And what this is due to is the expanding gases of the explosion rush out rapidly, and they displace the normal air around them. And you have a region of low pressure. And surrounding this is all of the compressed air of very high pressure. And then surrounding that, you have your normal air.
So as this area of low pressure air is forced to increase, it gets colder. And cold air makes clouds. So bizarrely, for a fraction of a second, you are looking at a cloud of water vapor.
There's some incredible physics going on here.
Proving the point that the bigger the bang, the better the science.
Normally, you would use a lighter or a match that would light a fuse. They're not doing that. What they're using is a touch-sensitive explosive. As he smashes the hammer down, the whack causes the chemicals to grind together. Now, if you imagine rubbing your hands together, you can feel them getting warm. And this is what happens with these chemicals, and this is the heat source that then sets off the explosive part of the firework. Rather than having to react with oxygen that's in the air, they've already got the oxygen mixed in with all of the fuel. And this means that when they get the heat source, all the chemicals are already mixed and ready to just go off, taking David with it.
OK, but what's responsible for David's airborne excursion?
That was Newton's law.
For every action, there has to be a reaction. So you have these gases blowing out, and instantly there's a reaction on the hammer to throw it back. It's the same way rockets work. If gas is going out, rocket goes up.
Luckily, all David lost was his hammer, but gained a legion of internet fans.